on it to isolate this DC voltage, then it doesn't put the powering, the phantom powering, on that particular LAN cable, and so it protects your desktop PC's LAN card from getting blown up. The implication of that, every device has to have their own dedicated access wire back to the wiring closet, where there's this special expensive box that then probes the terminal at the far end to see whether it can handle phantom powering or not. Is your LAN designed that way? Probably not. If we have already rebuilt the LAN, then yes, probably the way it looks is that from every jack in the wall, it goes back to a port on a switch in a wiring closet. But if your LAN has evolved over the last 20 years, which most of them have, chances are pretty good that there are all sorts of hubs and switches and stuff in the middle, and you don't have a scenario where there's a wire going from the wiring closet to each individual wall jack. Well, the solution to that is to buy an expensive phone. And the expensive telephone will plug into the LAN jack, and it will have the transformer on there so it can accept the phantom powering. But the phone will have a second feed-through, if you will, LAN jack on, and you take your computer and plug it into the telephone. And this way you can plug what we might refer to as a legacy Ethernet card onto the telephone, and the telephone will protect it against the phantom powering. And this is Cisco's solution to the problem. And one last caveat here. We're talking about now taking your computer and your voice communications and putting them over the same shared access wire going back to a wiring closet. And if we've got gigabit Ethernet on there right now, then that's probably not a problem. But what happens if we've deployed this whole solution, but it's actually only 100 megabit per second LAN connection? Now you've got both voice and data sharing the same access wire going back to the wiring closet. And are we going to start having voice quality problems if we do that? Well, we don't know. And the manufacturer might say, no problem, this will work fine over gigabit Ethernet, it'll work fine over 100 megabit per second Ethernet, but we don't recommend it over 10 megabit per second Ethernet. Well, are they going to guarantee that you can take your phone and your PC and have them share a single connection onto the LAN and it'll still work at 100 megabits per second if you're doing a huge file transfer and having a phone call at the same time? The word is guarantee here. This is what we're looking for. The salesman will say pretty much anything, but we want to have some tests done and some proof that if we take our desktop PC and plug it into the phone and we do a huge file transfer and try to make a phone call at the same time, do we have problems of not enough capacity and contention between the voice and data on the shared access wire back to the wiring closet? I want to know the answer to that question before I write the specification, not after. Save money replacing your PBX with generic general purpose computing hardware like Dell computers, and then a software application to do the telephone switching and voice over IP call management functions. And this is called replacing the PBX with a soft switch. Now this sounds good, it sounds attractive, because especially if you've been an administrator who's been having to pay Avaya or Nortel or Mitel or any of 100 other companies upgrades to hardware and software and telephones for their proprietary system that isn't compatible with anything else, now you've got the opportunity to break free of that yoke and use standards-based systems and general-purpose hardware, so you can mix and match. You can buy servers from one company, telephones from another, call management servers from a third, and you're going to end up saving quite a bit of money on hardware. And then buying a license to use a software program certainly is cheaper than buying a PBX. And you can end up with a new telephone system for a fraction of the price of a PBX. This sounds very attractive. The conventional wisdom is that the user interfaces on soft switches is better than on PBXs. Because PBXs come from a long history with a lot of baggage, And in 1981, the command line interface for a PBX was a ASCII VT100 terminal, and you had to type in little command line codes in order to add lines and change numbers and stuff like that. Whereas a soft switch product that was developed over the last 18 months, well, for sure, it's got a nice graphical user interface, and you might just be able to drag stuff from one place to another to establish connections. So the conventional wisdom is that you get a much better human-machine control interface on a soft switch than you do on a PBX. But how long is it going to work for before it crashes? And once it crashes, how long is it going to take before it comes back up again? And third, how often does that happen? This is called mean time to failure and then mean time to recovery, and the overall number is referred to as availability. Now, for PBXs, as we mentioned earlier, they've had a long time to get this all figured out, and their hardware is all redundant inside. There are two of everything, including two connections between the various chips inside on a PBX. If you're using general purpose stuff, then obviously you want to have duplicate servers, two call management servers, but then you need to have a system that does automatic protection switching. So if one fails, it automatically switches over to the other, and no phone calls get lost, and no session information gets lost, no voicemail messages get lost. Now, it's unclear as to whether some software package you're going to buy does this. Now, even if it says it does do this, who tested to see whether that actually works or not? Or do they just say it works in their brochures? They're going to try to sell you the system, and then they're going to test it out at your place, unbeknownst to you, to see whether it actually works or not. So we have to have a bit of caution when we're talking about buying software packages to do telephone stuff, because you can buy them from well-known companies like Nortel and Avaya. You've got a pretty warm, fuzzy feeling the stuff is going to work. Buying it from a company you may or may not have heard of before, you really don't have any idea as to whether it's going to work or not. So you really do need to test it to find out whether the availability specifications are going to be actually met in practice or not. Because finding out that they're not met in practice and the telephone system crashes 4 times a day, and sometimes it takes half an hour to get it back up, you're the one who's going to be ending up holding the short end of the stick. One last point to note, and this was actually brought up by a person who attended one of our public seminars, is they went down the soft switch road, and they worked with Cisco, and they got all of the various boxes, and they got licenses from a partner that was working with Cisco to do the actual switching function. And then what they found out is it wasn't just one software package that they had to buy to do the soft switch function. It was a whole bunch of separate ones. And when they added up the cost of the software licenses for all of this stuff, plus the cost of the hardware, it turned out that it would have been cheaper to get an Avaya PBX upgrade than it would have been to do the software switch, because of the license costs for all of the different pieces of the soft switch software that they ended up having to buy. And this is the experience of one company that went down this road, so it's something that you probably want to check out. If you've decided to go with the soft switch route, just before you sign the contract, have somebody take a real close look at what you have to pay for software licenses, especially on a recurring basis. The last slide in this chapter is one of my pet peeves, and here we're talking about multimedia integrated converged telephones. The reason why this is one of my pet peeves is because my first job working for Nortel's research labs was helping develop a product called the Display Phone. And what this was a telephone that had a little keyboard you could pull out, but the keys were too small to use your fingers. You had to use the end of a pencil to push them. But it had a keyboard, and it had a little screen, plus a telephone, and it had a 300 bit per second modem in it. So you could do multimedia communications at 300 bits per second with this tiny little keyboard and a screen about